Now we will simplify the first term. Now we will simplify the first term. So here n equal to 1, V max equal to what? Vm. Okay. The moment n is 1, what happens? The diode angle is 0. N equal to 1 gives diode angle equal to 0. So putting these things, what happens? V0 is becomes Vm by 2 pi into cos alpha minus cos beta plus E into delta I. Now we have to simplify the term delta I. For this, we will write the equations for the instantaneous output voltage V0. So from that only we get the delta I. So I am writing the expression for instantaneous output voltage. So my instantaneous output voltage V0 equal to Vm into sin omega t. Vm into sin omega t. For what? Alpha less than or equal to omega t less than or equal to beta. And my V0 equal to what? V0 equal to what? E for beta less than or equal to omega t less than or equal to 2 pi plus alpha. 2 pi plus alpha. Here what? SCR is off. And here my SCR is on. SCR is on. This gives me what? Delta Vs. This gives me what? Delta Vs. And this gives me delta E. Delta Vs is the duty ratio of Vs with respect to V0. Delta E is the duty ratio of E with respect to V0. Now we will write delta Vs and delta E values, and then we will prove that the sum of delta Vs and delta E is 1, and then we will simplify this expression. Now I am writing the delta Vs expression. Delta Vs is what? Duty ratio of Vs with respect to V0, meaning it is the duration for which Vs appears across V0 by time period. So Vs is appearing across V0 for the period beta minus alpha. So beta minus alpha divided by time period. Time period is 2 pi. Okay. Now I have to calculate delta E. Delta E is a duty ratio of E with respect to V0. Delta E is the duty ratio of E with respect to V0. Meaning what? It is the duration for which E appears across V0 divided by time period. E is appearing across V0 from beta to 2 pi plus alpha, meaning it is appearing for the interval 2 pi plus alpha minus beta. So how can I define delta E? Delta E is nothing but the duty ratio of E, meaning the duration for which E appears across V0. E is appearing across V0 for the period 2 pi plus alpha minus beta by 2 pi. Now just add these two. If you add these two, we get delta Vs plus delta E equal to what? Beta cancels, alpha cancels. I get 2 pi by 2 pi is equal to 1. Now what I have to do? Delta Vs plus delta E equal to 1. But I want delta E. Delta E is what? 1 minus delta Vs. Okay. So now I substitute delta E in terms of delta Vs and then I will simplify. Generally what happens is like in problems it is easy to calculate delta Vs. In problems it is easy to calculate delta Vs. That's why we are writing delta E in terms of delta Vs, and then we are doing the simplification. Otherwise also you can directly simplify delta E. This is very important point. If you can simplify delta E directly, it is very good. Okay? If you can simplify delta E directly, it is very good. But what happens is, like, in a given problem, while solving the problems, it is easy to write the expression for delta Vs. It is easy to write the expression for delta Vs. That's why I am converting this delta E into delta Vs. That's why I am writing delta E equal to 1 minus delta Vs. Otherwise, you can directly substitute delta E also. My delta E is 1 minus delta Vs. That equal to 1 minus delta Vs is the duty ratio of Vs with respect to V0. Meaning, it is the duration for which Vs appears across V0 divided by the time period. Vs appears from what to what? It appears from alpha to beta divided by time period. My time period is 2 pi. So 1 minus alpha to beta means beta is higher and alpha is lower value. That's why I take beta minus alpha divided by 2 pi. If I simplify this one, what I get is 2 pi plus alpha minus beta by 2 pi. So this is what? My delta E value. So that I will substitute. So what I get? Vm by 2 pi into cos alpha minus cos beta plus E into delta E. What is my delta E? 2 pi plus alpha minus beta by 2 pi. So the same thing I have got here also. This 2 pi is common to even E. So the same thing I have got. So both the expressions are giving, both the methods are giving the same value. But it is easier to calculate through generalized expression. Directly you write and then you make the substitution. If you practice this equation directly, you can decide diode angle, n value. So it doesn't become this much lengthy. You can straight away write in 2 steps, 2 or 3 steps. Here I have explained. That's why I have written so many lines. But in a given problem, what is n value, what is diode angle, what is V max. So if you practice what happens, you can straight away write these values directly, and then within 2 to 3 lines, you can come to the average output value. You can directly come to the average output value. So this is very easy to calculate. That's why this method is very simple one. Now you have to tell me what is AIR-DC, because you have seen so many loads and you have calculated AIR-DC in each and every load. So you tell me what is AIR-DC. The first step is everywhere it is same. First calculate V0 DC. And use this V0 DC for calculating AIR-DC. This is the procedure. This is the simplified procedure. Even after telling repeatedly, you want to calculate directly AIR-DC. That is not correct. First you calculate V0 DC and then you calculate the AIR-DC. V0 DC comes through generalized expression. Now, given V0 DC, we will find the AIR-DC for RLE load. So, V0 DC is given. This is R, this is L, this is E, and this is my instantaneous voltage, and this is I0. Now, I have applied the DC voltage. So, if I apply the KVL here, the DC voltage here equal to the DC voltage here plus DC voltage here plus the DC voltage here. The DC voltage across inductor is 0. This I have told you n number of times. Okay. For this you can refer to our chapter on basics. Why the average voltage across inductor is 0. V and DC is 0. For this you refer to our chapter on basics. What is the average voltage across E? The average voltage across E is E, that is battery. It is having constant voltage with respect to time. With respect to time, it is having the constant voltage. Okay. With respect to time, it is having constant voltage. So instantaneous voltage, peak voltage, RMS, average, everything it remains E. So the average voltage across E is E. The average voltage across inductor is 0. The average voltage across R, that is VRDC. This is not 0. VRDC. Now you apply the KVL. That is V0DC equal to VRDC. V and DC it is 0. That's why I am not writing it. Plus E. What is VRDC? VRDC is nothing but I0DC. That is the output average current times R plus E. I want to calculate I0DC. So after simplifying this, I0DC equal to V0DC minus E by R. This can be taken as a formula. For RLE load, given V0DC, the I0DC is given by V0DC minus E by R for RLE load. For RLE load. Now I have to calculate the power factor. That is more specifically the input power factor, IPF, the input power factor. So for calculating the power factor, the funda is we have to equate the power equation. That is power delivered equal to the power observed. Power delivered equal to power observed. Power observed. Power delivered, it is by the source. Power observed, it is by the load. Power delivered by the source is Vs RMS into IS RMS cos phi. These are the RMS source voltage and RMS source current equal to the power absorbed by the load. I have what kind of load? RLE. So power absorbed by the load is nothing but power absorbed in the resistor plus power absorbed in the inductor plus power absorbed in the E, that is the voltage source. Power absorbed by the resistor is nothing but I0 RMS square into R. Power absorbed in the inductor, it is 0. It is 0. The power absorbed in the battery is I0 average into E. So you have to know this one. The power absorbed in the battery is I0 average into E. It is not I0 RMS into E. Many times the students do mistake. They simply put I0 RMS into E. This is not correct. For battery, if you want the power calculation, you have to take I naught average into V, that is the average current flowing through the battery, into E, that is the voltage source value. So for this you refer to our basics. Now I have to calculate cos phi. Cos phi equal to what? Cos phi equal to what? I naught RMS square into R plus I naught average into E by Vs RMS into IS RMS. Generally, calculation of I naught RMS is very tough. Very tough. I have told you, like if you want to calculate I naught RMS, you have to know the V naught RMS and its components, like how much is the DC, how much is the harmonics, fundamental. Each one you have to know. If you know this one, if you know DC, fundamental and harmonic separately, you have to calculate the corresponding values like DC current value, fundamental current value and the harmonic current value, and then you can calculate the I naught RMS square. This is very complicated procedure, but if I naught RMS has to be found, means you have to use this one only. There is no shortcut. It is very complicated.